This is Dave, aka the Guru, and another tutorial on using GameSalad. In this video, we're going to talk about the code scan, and we're going to talk about logic order and how the code scan work together. So in working with GameSalad, when you have games or elements that rely on the speed at which variables and attributes and conditions are changing, it's imperative that we really pay attention to the order in which our logic is structured. Now, the one thing about logic is we all understand what logic really means in its essence. Logic is conditional values or things that happen in a sequence. And so that is, a sequence would be numbers, as we know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say, for example, this is a string of logical numbers. Each one precedes the next in the same fashion. In other words, that one is added to the next one in the order. And so we never break this order. In other words, 1 has to come before 2, 2 has to come before 3, 3 comes before 4, etc. This is what we call logic, or a linear analysis of how things are done. So in GameSalad and any computer code, basically, the scan of the system or the scan of the code is done in a linear or logical fashion. And this is determined by the order as far as GameSalad is concerned. This is done in the manner in which things are placed, either within actors or within the layers. And now it's critical when we have fast-moving games and we have lots of logic. Since code in a 60 frames per second game is essentially scanned every 300ths of a second, we tend to take for granted the speed at which this happens, which is fine for smaller projects and projects with code that don't rely on the quick initiation of discerning whether a variable or a condition has changed in the code. When we start to get into longer scans, that is, where we have more and more code, more and more actors to go through the scan, we can begin, if we don't logically order our code as best we can in the proper manner, some of our code can actually become a half a scan behind or even a full scan behind, which is what is discerned or called in the game environment as lag. This is when relevant data can't keep up with the previous changes in conditions in our game. Now, in small games, this doesn't become an issue because generally the conditions and events that are happening are not happening quickly enough in order to cause disruption or skips or gaps in our logic being able to recognize when things change so quickly. Now, in this example that I have here is my multi-touch template, where I'm able to do up to 11 simultaneous touches at one time. This kind of code, which relies on touches that happen relatively fast, sometimes they can almost happen simultaneously, which means it's really pushing the boundaries of each scan, since touch happens so fast and the conditions can change so quickly from when I grab one thing or another, or the fact that I can grab something and change conditions in the middle of a scan. This can affect the performance of how this template works. In fact, this template cannot work unless all the code and all the actors are placed in the proper arrangement based on the code scan. And I'm going to demonstrate this here momentarily on how simply moving my manager actor that has the algorithm that calculates through each scan what the current condition of every actor is and where they're getting their touch count will literally break this game to be unusable. This is a very extreme example of how fast-moving code needs to be set in a linear or logical fashion, that we need to understand the elements of our condition and what's happening when, and make sure we order or structure things the best way possible. Now, sometimes we can't do it. So let's go over quickly how code is done in, let's say, a actor. So it's critical to understand that in GameSalad, specifically, we're going to be talking about how the code is scanned in GameSalad. So let's see, I'm getting a little, because I've got a lot going on here in my screen sharing my device, and I'm recording and doing, so I'm getting a little lag. So in this actor, you can see that I don't have a whole lot of stuff. I have a series or a handful of rules with a couple constraints attributes are, and what they do is they monitor, each actor monitors the self touch count. In other words, what touch is assigned to it. And that touch gets assigned by my assignment manager. So you can see here that basically all my code happens in a linear fashion. So in GameSalad, code is scanned in an actor linearly from top to bottom. So the code comes in, it looks at this behavior first, then this behavior, which includes the things that are inside of it, the attributes. Okay, it looks to this first, then goes to this and this, then looks at this one, then goes to this and this in a linear or logical fashion. So as you can see, I've arranged my code based on their attributes with how the code is going to look at things first. I'm going to start in a numerical proper way. So it's going to look at this self-touch count. And so the first one that is always available when I'm not touching is 1. And then the next one will linearly be 2, 3, 4, 5, 6, 7, 8, 9, 10 as I go along. And so the code is going to naturally scan through, and 1 comes before 2, 2 comes before 3, etc., which all works fine. This is a general optimization of how things are going to get underway in my code. And then once the manager takes over, as I start lifting things and the numbers become in between numbers in Multitouch, then it starts to go through the scan and look for the available touch count. So now in multiplayer, it's always the lowest touch count that you want to go to. So if I have my fingers on 1, 2, 3, 4, let's say, and then I lift 2, the next touch that I make is going to want to go to the touch 2. And the touch 2 instances in GameSalad, okay? So now this meets my progression. In other words, I'm always going to be looking for the lowest number first. So keeping these things in order from lowest to highest in my scan rate is going to help facilitate that happening as quickly as possible. So if I were to have variables in here, and this could be any variable in my code, if I was saying, okay, I'm looking at this variable and then I'm going to change some things, I would want my next rules that are related to these changes to be next in the order, not above the change, but after the change. So I have to look at my attributes and my conditions based on what I'm changing when, and make sure that downstream, whatever code affects the changes that I make above are the ones below. I want to be the things that are monitoring what's happening above in my code. In the same way for which we order actors, when we order actors in layers, okay, in here, the code now scans from bottom to top. So in other words, it's going to scan the code in these actors first, all the way to the top, and then loop around again and go this way. So if I have actors that are affecting the overall conditions of other actors, I want to make sure that those actors with those conditions are at the head of the code scan, if possible. Now, layering becomes an important element. You're never going to get an 100% perfect linear code scan in your code, but most code dies a slow death of 1,000 pinpricks. So in other words, what I mean is if you have all kinds of actors in your code, and your code is willy-nilly, and things are not structured in a way to make sure that when changes happen, the things that are monitoring is after in the scan, then what happens is, let's say, for example, I have an actor here that has conditions in it. And when those conditions change, okay, in this actor, the first actors that are going to see that change in the scan are going to be these actors. And then it's not until it comes around to the new scan that these other actors are going to pick up on the conditions that changed in this one actor. So what this means is that essentially what's going to happen is these actors below are going to be a half a scan behind my actors that are above it, because they're going to see the conditions change in that particular scan, and these actors down here are not going to see that change in my code until the next scan. So this is why it's important that we try our best to plan out our code so that my conditions that are generally changing a lot are at the head of my scan, so that once they change, all the actors and all the code in my scene see those changes at the same point in time, which is in the same scan. And so if you have code firing all over the place, you're going to have some actors that are seeing the change in the scan and other actors that are seeing the change in the half of the scan or within a whole scan apart. And so this is why it's important that we collect our code, understand how our logic talks to each other, and make sure our conditions are seeing each other in as linear a fashion as we can possibly do it. Now, there are constraints that are going to happen, like how you want things layered. There are always gives and takes in these things. You're never going to get it 100% perfect because you have other things that are going to take precedence over having the perfect scan, like how things are layered and what you want on top and what you want on bottom. So the idea is to build your code with the understanding of what's at the bottom and what's at the top. So if I have a hero actor that I want to be on the top, I might add more conditional codes in him so that he's at the top of the scan. So when things change in him, all the other actors will fall in line because they'll all, at the start of the scan, they'll all be in sync with what happened. Instead of putting certain things in my platform, I might export that stuff out. This is why we don't put non-relevant actor code into just actors all over the place. Most veteran coders take that code and put it in managing actors that can be at the top of the scan or can be in the scan where we want to put them, because we're thinking of our code overall and not just in particular segments. And this is how your code gets all out of line and ultimately in big games has a big relevance to performance because you're breaking the scan. You're breaking the linear. So the best way to do it is to keep all your code in a linear fashion. Think about the conditions in your rules and what you're changing inside those rules, and make sure that everything is below each other in how things execute. You have to think about it in your head in a linear fashion, not just in the GUI. You have to look and say, oh, I'm changing this size, and then when I change this size, I want this to happen. So that code that executes after something like the size is changed, you want to make sure that's below the sign code. And any other actors or code that is relevant to that you've executed, you want to make sure it is past that actor in the scan. So let's look at this game real quick. I'm going to go ahead and I'm going to it's in the proper scan. So what I've done is I've put since I'm touching first, so what happens is these things are collisions and they're just in the bottom. There's no real code in them. So I'm going to let they'll scan first. And then what I'm going to do is I'm going to come into all these actors, that other things I'm going to be touching. And when I get to the end of all my touches, this manager is going to evaluate all those touches and make sure everything gets assigned properly for the next round of touching. So the linear scan is going to happen this way. So all the events are going to happen. The manager is going to sort through everything. And then as we come back to the scan again, everything's going to be already arranged and sorted. And all these things will be in sync as we go through. And then the touch manager, once again, will assess everything and then come through again. And I'm going to show you how simply moving this actor is going to break this game. So let's go ahead, and I'm going to go ahead and preview this on the viewer. And then I'm going to go ahead and I'm going to bring this up in Reflector. So here's my little app, and everything is properly organized. So what I'm going to do is I'm going to grab a bunch of different stuff and move it around here. I've only got so many fingers, so let me just grab a few things. And you can see everything's working in order. I can lift stuff and I can do, everything's kind of freaking out a little bit because I'm doing a lot on my computer. So there we have that. So now let's go ahead and let's go into the layers, and let's go ahead and let me take this managing actor and I'm going to move it into the middle of the scan. And so now let's see what happens now that I've done this. So let's go ahead and bring this up. Let's bring Reflector up. And there it is. And let me start. Oh, all of a sudden, look at everything's all a mess. Things are flying all over the place because now I've broken the scan in half. So now some of the things are going to work. The actors that are in the top half of the scan, as you can see, are kind of these ones here. I'm grabbing them and they're working now. Those are coming together. They're working into the same touch, as you can see. And now this stuff over here, some of it works, okay, and some of it just flips out because I've broken the scan, and this all happens so fast that the scanning manager can't organize everything. And I've sent my code into disarray. So this whole premise, this whole template can't work unless I know and understand how to do my what's going on in the scan order. And so this is a prime example of how things on a collected level throw off your code. And this is a prime example of how the scan order or the code order has to be done in a proper manner. Because things and events are happening so fast, it's important that everything be perfectly aligned and perfectly arranged in order to do this multi-touch scenario. You can't do this any other way. Myself and Arlamine have been through all this code. We both are like the only two that have ever built this kind of multi-touch system, because it simply can't be done if you don't pay attention to your code order and understand how to build your structured logic. It's impossible. This is the only way with perfectly aligned and managed code to be able to do this template, to be able to do an 11-touch instantaneous multi-touch system like this. And so this is just with small branches of code that happen quickly. But as you build out your code in a big game, and all these little pinpricks start to drag down the performance of your game, and you can actually skip conditions and skip events you wanted to happen. If I had something in this actor that I wanted to trigger, and then I wanted it to happen, and then, I have another actor up here that's going to change the condition. So if I have an actor down here that's monitoring a condition, and then I had another one here that does something, and another one. So if I went through and this changed, and I expected something to happen, and then this actor changes it, by the time I come back around, this actor at the bottom never sees that change. And so it essentially skips over what's supposed to happen in your code. And this is what happens when you build out big games with lots of branches of logic and lots of things that your logic is just dragged in and things are placed everywhere, and you're not taking the time to see your code in a linear, logical fashion. You have to see it in how it's firing in a series of events and line your code up as best you can to properly develop a scenario in which everything fires within as best it can within the scan, or can allow for jumping of the scan to come back. Those things have to take into consideration, especially if you have large projects with lots of code and lots of actors. If things aren't ordered in a way that fits the logic, your projects will break, your projects won't function as they should, just like I demonstrated here. By simply moving an actor into the middle of the scan, I break this project. This happens in small levels on your projects. Some of it, you can get away with it. But other times, you can't, and you don't notice it. And so, for good performing projects, your code and your logic needs to be in order. Now, myself and Hopscotch discussed this in my last Game Salad Guru live stream, because he and I have very rarely seen projects break, slow down. We're always able to get good performance. Why is that? That is because the main thing that we do in building our logic is paying attention to how we're building it, how each works off of one another. We're both very good and very skilled in logic, and we see our projects as a whole and our code as a whole, and we plan out our code as a whole. And so in our projects, our logic is always refined into the process of what happens when. And we make sure that everything conditionally and everything that we're doing is done in a logical order based on the scan rates, based on how things are scanned and how things are monitored in Game Salad. And once you understand and start paying attention to the little elements of your code of when you're changing things, and then making sure those things that are affected by those changes are downstream in the scan, you'll see a rise overall in your performance if you do that overall through the structure of your code, because now you're defining and building your code in a way that the machine can efficiently process it. If you're jumping all over the place with your logic, you're going to have to wait code cycles in order for those changes to become acknowledged, and this causes slowdowns because it's taking more scans to get the code sorted than if you put it in a position to be able to order the code and monitor the conditions within the scan, instead of waiting multiple scans for it to see and define and sort those changes. So we're going to talk about that more this Sunday, and I'm going to show you examples of what I mean in more detail so you can gain an understanding of what I'm talking about and actually see it in being done in the game salad logic, so I can help to bring you more into looking behind the scenes and seeing your code as linear events and not so much as just behaviors and conditions, but how those conditions and behaviors line up and how they affect each other, and the best ways to learn to look at your code in logical fashion and sort things based within the code, and understand looking at your code in a detailed fashion of all lined up in a series of events. So I hope this helps many of you to begin to understand lining up and bringing better performance into your games by paying attention to the scan and the code order in your logic. So anyways, this is Dave, aka the Guru. I'll see you in the next video.